the new topic called storage structure. Now, in our computer system, what are the different storage areas or storage devices we have, that we'll see one by one and try to understand all the storage devices. The storage, what is the meaning of storage? Storage means where we store our data, or where we'll store some sort of data. Either we'll store for a smaller period of time or for a larger period of time. Okay. So the first storage here, it is called main memory. So main memory is the only large storage media that CPU can access directly. What it is saying that the CPU, I have shown you the structure where we have a CPU and we have the RAM, okay, and we have the hard drive. So CPU will access the data from the main memory, okay, and all the processor and all the program which is ready to run should be in main memory. So that's why here it is says that this main memory is the only large storage area that the CPU can access. So CPU will access which memory directly, on which is the largest memory that CPU will access. So the answer is main memory. Main memory will be accessed by the CPU directly. And what is that main memory? So main memory, the access from the main memory is not a linear access. We have the random access. So randomly we can go to the location of the memory and we can access the data from that location of the main memory. Second property of a main memory is the main memory is volatile. So what is the meaning of volatile? The meaning of volatile is that whenever we reboot our system, the memory area will be flush off and there will be no data available. So that property is called volatile. Volatile means, so whenever we reboot, or when there is no power in your system and will not provide any power to the main memory, so we cannot store anything. And if there is no power in the main memory, there will be no data in the main memory. So when we boot up, and at the time of when my system is working and it is in the working condition and power is inside the system, it means that power is inside the main memory. So definitely it can have this data available. So whenever we have the power to the main memory, we can store the data. If it doesn't have the power into the main memory, we cannot store the data. That's all. So that is called volatile property of the main memory. So yesterday I told you that this main memory is called RAM, right? So this is called random access memory. RAM, random access memory. Why the name suggests random access? And because this property, it is called random access memory. Okay. And particularly we are using DRAM, which is called a dynamic RAM. It is called dynamic RAM, DRAM. There is also SRAM available, which is called static RAM. This static RAM is not a main memory. This DRAM is a main memory. Okay. And I'll discuss about what is SRAM and what is DRAM and how it works in detail whenever we got the topic available. So till now you remember that DRAM is called your main memory, and every RAM which is working as a main memory, we say it is a DRAM, dynamic random access memory. Now we have the secondary memory, secondary storage, extension of main memory that provide large non-volatile storage capability. So the secondary memory, whatever secondary memory will use, that secondary memory is a larger memory, and it is comes into the category of non-volatile storage memory or non-volatile memory. So we have two type of memories. So first one is the primary memory, by which CPU will direct interact, and we have the secondary memory, and from the secondary memory this main memory will directly interact. Okay, this main memory will directly interact. So it will be like this. So we have secondary memory, we have main memory, and we have CPU. So from the main memory, CPU will interact, and from the secondary memory, main memory will going to interact. So CPU is not going to interact with secondary memory. The reason the reason of this particular architecture is because the CPU has some sort of uh, instruction. There is a instruction clock, or you can say the processing capability, or the speed, you can say. So the speed of executing any instruction in the CPU is very large. So you can say the speed of processing anything in the CPU is very large. To meet up, secondary memory cannot match it. Why? Because in the secondary memory, the data speed or the data from a secondary memory, if we want to fetch and we want to give to the CPU, so always there is a lack of time, and this lack of time cannot be matched with the CPU. So if we want to take from secondary memory to CPU, your system will be very slow. So that's why the scientist has given this architecture where we have the main memory, which has a good speed. Definitely, it cannot match the speed of the CPU. Let's say this, the CPU speed is, let's say, 1.2 megahertz or 2.4 gigahertz. Sorry, not giga. It should be mega. Sorry, not mega. It should be giga. So let's say the speed of the CPU is 1.2 gigahertz or 2.4 gigahertz is, let's say, the CPU speed. Okay, and here the main memory and the secondary memory has very less speed, and that speed cannot be matched with the CPU. In between main memory and CPU, there are some memories that we'll see, but in the computer architecture, it will look like this. So we have secondary memory, then main memory, and then CPU. And the reason behind all these hierarchies are because of the speed of these devices. So the speed of these devices are very large, and all these memories are connected with each other with the high-speed bus. So for the connectivity, we have high-speed bus, and all are in the motherboard. So you see, when you see the motherboard, and in the motherboard will put all those devices and will connect all those devices. And in the motherboard, there is high-speed data bus, which is responsible for sending and receiving the data from one device to another device. Let's go to the secondary storage or secondary memory. So you see secondary memory, we have two options. One is the hard disk, which is also called magnetic disk. And the second option we have is a solid state disk, right? SSD. And so we have SSD and hard drive. So what is hard drive? So hard drive, it is with the metal or glass platters are there, which is covered with the magnetic recording material. So that's why it is called magnetic disc. So there is a disc called platter, and this platter is covered with the magnetic recording materials, and that's why it is also called magnetic disc. So your hard drive or secondary memory or secondary storage, it is also called magnetic disc. Disk surface is logically divided into tracks, which are subdivided into sectors. So you can see that sector is the smallest way we can store the data. So I'll let you know about in the detail that what is this and how it look like. The disk controller determines the logical interaction between the devices and the computer. So there are disk controller, or you can say some sort of device drivers, which are responsible for making the interaction with the device and the computer. It means with the device and your operating system. So operating system are nothing but what we have different in the operating system. What we have kernel, we have uh, device drivers, okay, so we have device drivers or device controllers. Then we have many functions, okay, that is called your that is called system function. Okay, so there are system functions that are available, and there are many other things. So we'll see one by one when it will reveal. So you know there is a kernel. As I told you, the kernel is the heart and soul of the operating system. Then we have many device drivers available in the operating system, or it might be the part of the operating system or might not be the part of the operating system. So we have the concept of monolithic kernel and monolithic kernel and microkernel. So if we have microkernel available with us, so the kernel size is very less, or you see that kernel size is very less, and this device driver and system functions are outer part of it. And if we have a monolithic kernel like this Linux operating system, then all are fetched together. Kernel, device driver, system functions, and all those are fetched together and made one unit on the kernel. Okay, so we'll see that in detail whenever the topic will come. We'll see what are the component which is inside the operating system. So here, what we are learning here is we have two type of memory. One is the hard disk, which is called magnetic disk, and another disk is the solid state disk, which is more faster than the hard disk. It is also in the category of non-volatile memory. Non-volatile memory means if we give the power to the hard drive or to that particular disk, the you can have this data with you. If you will not give the power of it, the data still be there in that particular system. This solid state disk has been made with various technology and become more popular because of the speed. Because of the speed, nowadays solid state disk is more popular. Let's see the difference between hard disk and solid state disk, that how it look like. So let's go first the hard disk or hard disk magnetic disk. So you can see that it look like this. If you have a hard disk, that hard disk will look like this. If you see this particular diagram, you will find it out that there is some sort of disk available, and the disk is this particular disk is coated with the magnetic material. That's why it is called magnetic disk. This particular part, you can say this particular part is called read-write head. Okay, this particular part is called read-write head, and this read-write head is of both the side of the platter. It is an upper side as well as lower side of the platter. So let's see this particular diagram and try to understand that how your disk look like. So we have a read-write head. This is my read-write head. So we have, see, if we have 3 disks available, so we have how many read-write head? We have 6 read-write head. One read-write head is for one part of the surface. Another read-write head is with another part of the surface. So in the hard drive, here I told you this is the ARM, and with this particular ARM assembly, all the read-write head is connected. So if we have, let's say, 3 platter available, this is called platter. Platter has 2 surfaces. So we have bottom surfaces, we have up surfaces. In both the surfaces, we can read and write. Unlike your CD-ROM, CD-ROM has only one surface, but here we have 2 surfaces available. And this is the magnetic material which is responsible for storing the data. All these disks are connected with the rotor, and this rotor is moving in a clockwise direction. And your read-write head is moving in one particular direction, either in this direction or this direction. It is going to move your read-write head. In that way, read-write head can reach each and every part of the disk. If we'll make a circle in the disk, that particular circle is called track. And inside the circle, if we further divide that particular circle, that is called sector. So you can see the sector is the smallest part where we can store the data. 12 byte. Okay. So 512 byte is the sector size, and this is the size of the block which is used to store in the hard drive. This is the smallest part. So as I told you, this is a platter, track, sector, and when we combine all the circle of that particular same position of all the disks, that is called cylinder. Okay, that particular portion, if we'll combine all the disk circle, a particular location of the circle, then it is called cylinder. It looks like cylinder, that's why it is called cylinder. So these are related to the hard disk, and the speed of this particular rotation is maybe 5,400 RPM or 7,200 RPM. It depends upon which type of hard drive we have used in our computer system. So it is the standard speed, and based on that, the speed of the data transmission is depend upon this speed, the rotation speed. Okay, rotation speed of the cylinder. So if we are rotating it, the rotating capability will be faster. So definitely your your data transmission will be faster. And if the data transmission will be faster, definitely we can say that it is a faster hard drive, or it is a fast hard drive. But faster than the hard drive we have is solid state disks. What is this solid state disk? SSD. That is SSD, right? Solid state disk. Now in the solid state disk, there is no mechanical part. There is all electronic part. And let me tell you, we have this SSD is nothing but the combination of flash drive. What is flash drive? You all know what is flash drive. Flash drive is nothing but we say it is a pen drive. The technology that we use in the pen drive and we use in SD, this SD and SSD drives, that technology we'll use here for the SSD. Here we have many SSDs, many flash drive available. Let's say we have, these are the flash drive. This is flash drive 1, flash drive 2. This is third flash drive. This is fifth. This is, this is fifth. This is sixth. This is seventh. And this is eight. Let's say 8 flash drives are available. So we have 8 flash drive, and combination of that is the capacity of this SSD. We have a controller here. We have a controller, or you can say microcontroller, which will control, I don't know whether this part is a microcontroller or not, but there is a microcontroller available in the SSD, and there is a cache memory is also available. Cache memory is nothing but a small size, very fast memory available, which will store very frequently used data. So let's say, or the recently used data, you can say. So most recently used data will be stored into the cache memory. And whenever a CPU require, or whenever your main memory require the same data for you, so you can actually use it, right? So that's why it is very good, and it is very fast. So nowadays, many system is with SSD drive also. We have magnetic disk as well as we have SSD drive. And this SSD drive will store the most recently used data, and the price of both the magnetic disk and SSD drive are not the same. SSD drive are more expensive than your magnetic disk. Okay. But now company are making SSD drive, and I think that there will be enhancement in the hardware, and definitely it will be more cheaper. So in future, we hope that the solid state drive will be more cheaper than the hard disk drive. But let me tell you, the life of SSD is less than the life of magnetic disk in terms of data storage. So it will store the data for a larger period of time. Which one? The magnetic disk will store the data for a larger period of time than the flash drive. Okay. So that is the difference between these two. So in the magnetic, so cache memory is a special very high speed memory. It is used to speed up and synchronize with high speed CPU. Now the high speed CPU, as I told you, the speed of the CPU is maybe 1.2 gigahertz of frequency speed, or 2.4 gigahertz. So to match this particular speed, the main memory cannot do that. So main memory doesn't have that much of capability, which can transmit the data to the CPU at that particular high speed. So to match with that, we use another type of memory, which is called cache memory or cache memory. Okay, whatever pronunciation you do, you can do. This cache memory is costlier than the main memory. So definitely it is costlier because the speed is very high. Or disk memory, but economical than CPU registers. So I'll show you, or I'll tell you what a CPU register is. So here it is saying that it is costlier than main memory and definitely the disk memory or the secondary memory, but economical than CPU registers. There are CPU register. So if we'll compare with the CPU register, it is economical to that. Cache memory is an extremely fast memory type that acts as a buffer between RAM and the CPU. So as I told you, we have secondary memory, we have main memory, and we have CPU. We have secondary memory, we have main memory, and we have CPU. So CPU will interact with the RAM, and RAM will interact with the secondary memory. But in between the RAM and the CPU, there is another type of memory. It's called cache memory. And this cache memory will store the data which is most recently used by the CPU, so that the speed will be match up with the CPU. Okay. Okay. It holds frequently requested data and instruction so that they are immediately available to the CPU when needed. So as I told you, it is most recently used data or the instruction will be there in the cache memory, so that the CPU will get that particular data whenever it is required at a very fast speed. It provides uniform interface between the kernel and the controller and the kernel. Which one? The cache memory will provide a uniform interface between controller and the kernel. Let's go and see this particular architecture. So let's say if we have some high-speed RAM like DDR RAM, okay, DDR 1 point something and 2 point something. There are many version of DDR, okay, some version, and some of the version are very fast, and this may match the speed of the CPU. But you know that today's computer system, there is no one CPU available. There are in one CPU there are different cores available, and each core is working or acting as one CPU. So you see, when the speed of one core is let's say 2.5 gigahertz, so you assume that all the cores has how many requests will fetch into the main memory, and how much faster it is the request. So to fulfill that particular speed, we required some sort of cache memory. So the cache memory is in between your main memory. This is your main memory which is available. So let me write it here. So this is your main memory. Right? And this is your cache memory. So as we have discussed that CPU is directly connected with the main memory. No, it is not, because in between there is a cache memory. And you see here, this cache memory is called SRAM. SRAM means static RAM. And this main memory is called dynamic RAM. So the cost of per bit storage in the RAM is like per bit will be stored in per cell, and one cell will be made of one capacitor is there, one voltage circuitry will be there, which is an input output way, and there is another controller are there, or a microcontroller, small microcontrollers are there. In the RAM, for the per bit storage, we required 6 cell. So it is costlier than that. So it is 6 times costlier than DRAM, you can see. So to store 1 bit in SRAM, we required 6 cell, and one cell is, as I told you, made of with one capacitor, or you can say the combination of the flip-flop, where we'll store the data or the voltage, the bit in the form of voltage. Either it will be a 0 volt or some sort of 2 voltage in that particular capacitor, which will tell us that it is a 1 bit or 0 bit. So that's why it is 6 times costlier than RAM, first of all. That's why we do not make the RAM size very bigger, because for responsible for storing 1 bit, it required 6 cell, and in the RAM for per bit, it required 1 cell to store one cell. So definitely it is more dense. And if we want to create, let's say, 4 GB of SRAM, it will be more costlier, 6 times more costlier than RAM, and the circuitry will be more complex. So that's why the size of the cache memory is very smaller, as well as because it is costlier, and uh, it is very high speed. High speed means definitely if we have a small memory, and so here the read write way of using that is making it a very high speed. Internally, how it is working, the SRAM, how SRAM is working, how DRAM is working, I'll take another session for that. For today, you just assume that the cache memory is costlier than the main memory, as well as faster than the main memory. So that's why we use as an interface between the main memory and the CPU. So it is acting as that. So I think you understood where we have to place the cache memory. So you see, here we have 3 type of cache memory available. First one is called level. Okay, so there is some spelling mistake. It will be level 1, then there is a level 2, and then there is level 3. So this is, yeah. So this is level 1, which is called L1 cache. The L1 cache is attached with each and every CPU. So inside the CPU, we have cache. This is this one, you can say this is L1 cache. This is L1 cache. So so this is one CPU, and there are different cores of it. So you can say that this is one processor, this is another processor, this is another processor. So we have 4 processor available in our, let's say, 4 processor CPU. Or if we have a 8 processor, we have 8 core CPU, then 8 processor will be there. So the cache is inside the CPU, and this particular is called L1. Here, the memory size of these type of L1 cache is 2 KB to 64 KB. And what we'll store here, so in the level 1 cache, we'll store the data and the instruction. So we have 2 type of cache area in each and every cache inside the each and every core. So this particular has 2 parts, you can say. One part will store the instruction, another part will store the data. One part will store the instruction, another part will store the data, in that way. And the memory size, it is from 2 KB to 64 KB, depend upon the processor to processor. This is called L1 cache. Let's go and try to understand what is L2 cache. So what is L2 cache? L2 cache is outside the CPU. This is L2 cache. It is slower than L1 cache, and the size, it will be 256 KB to 512 KB. And this particular L2 cache is, you can see that so this is your L2 cache, you can say. This is your L2 cache, which is outside the CPU. It is slower than L1 cache. Then we have L3 cache. L3 cache is again slower than L1 and L2, but and the size is 1 MB to 8 MB. But let me remind you, this L3, the speed is slower, but it is more faster than RAM, or more faster than the main memory. Okay, so there may be the hierarchy of it. Let's say we have, let's say this is a CPU or your one processor. Then L1 will be residing here. Let's assume that L1 is here. Then we have L2 cache, from which your CPU will take the data. Then we have L3 cache. So L3 cache, from where L2 will take the data, and from L3 there is a main memory. Okay, so main memory, and then there is a secondary memory, right? So this is how your hierarchy is. In some system you will get L1, L2 and L3. In some system you will get L2 or L3 or L2, L3. Okay, so it depends upon which type of processor and what architecture or what configuration you are taking for your computer system. So this is all about cache. So I think you understood what is the meaning of cache. Cache is nothing but faster memory and will store only the recently used data there, which will be useful for the CPU right now. So whatever the data which is useful or recently used for the CPU, will store those data into the cache memory. And this particular cache memory size is small. The reason is it is very costlier than main memory. And there are three type of cache memory available: L1, L2 and L3. L1 is inside the CPU or inside the processor. L2 is outside the processor, and L3 is again slower than that. It is also outside the processor, slower than L1 and L2 cache. So this is all about your cache memory, which we say cache. Or so all this memory is required to send the data from this, let's say, the hard drive to the RAM and to the cache memory, and ultimately to the CPU, because every data will be processed into the CPU. So that's why it is required, and we have to send all these data to the CPU, and from the CPU the result will be again go back into that particular hierarchy of the memory. So this is the process flow, that how your data is going to process. So it is start with the hard drive or the secondary memory. So from the secondary memory, it can go to the, from the secondary memory, the data will go to the main memory. From the main memory, it will go to the L3 cache. From the L3 cache, it will go to the L2 cache. From L2, it will go to the L1. And this, let me tell you, this L1, in the L1 cache, L1 cache is inside the CPU, right? It is looking like it is outside the, but it is inside the CPU. And from the L1 cache, the data will go inside, go to the CPU. And if in the cache memory, if the instruction which is required by the CPU is available, that is called cache hit. And if the instruction is not there in the cache, it is called cache miss. So that is a phenomena which we use. So if any instruction is required and it is there in the cache, in any, if let's say if the instruction is there in L1 cache, that phenomena is called cache hit. Let's say we are looking for L1, it is not there. We are looking for L2, it is not there. Then it is called cache miss. It is not there in L3. It is also called cache miss for L3. If it is not there in a RAM, that is also called miss. And then it will request to the hard drive to load that particular data into the RAM, and from the RAM it will take to L3 and then L2 and then L1 and then CPU. So this is how your data flow take place into the computer system.